Hey guys, welcome to my Java crash course where you can learn the basics of Java in just 45 minutes. So I strongly urge that you code along with me and practice the stuff that you've learned in this video after in your own time if you can, of course. So enjoy. So let's get stuck into this quick crash course of the basics of Java. So this is kind of an entry-level application that we created actually when we did the setup. So if you need to install Java and you need to install IntelliJ IDE, which is a IDE, integrated development environment. It's just a fancy way of saying this is the application that you can write your Java in, and it has some really cool features to get you kind of up and going really quickly, and it does like some really cool things like it auto completes and searches your code to give you information and stuff like that. I'll show you kind of as we go along. So let's get started. So what we have here is I've actually deleted the print, but what it had before is it had a hello world, and this was kind of like our entry point of our application. So the public static void main is just the entry point of the application in terms of when you run your application, Java is going to look for a public static void main method, and it will execute the code from here to here. So whatever's in this block, it's going to execute. This is just the name of the file basically. So a class is just a file in Java. So like right now we can create a new class called new class, for example, and you see here it's just create a new file. And do you know what? This can also have a main method, but the application will only run from one entry point, and it will only run the lines from here to here. So if this was called hello world 2, this would absolutely run. So this would run, but if you ran it from here, it would run just hello world. Okay, so you notice here as well we've now got two options. This is an old one I was playing around with a while back, so ignore that one. But see, we've got new class and we've got the original main. So let's delete this as we don't really need this anymore. So I'm just going to delete that. Just you can right click and just click delete. So now let's get into some proper like coding with Java. And the main thing you'd want to do with programming is you want to kind of manipulate data, right? And to manipulate data, you kind of need to store that data in something, and that's what's called as variables. A variable is a container where you can put a value in it. Now to declare a variable, you need to know the type. So the first thing is the type. The next thing you need is a name, and the next thing you need to do is assign this a value. So this is basically how it would look, and you end it with a semicolon. So you actually have to give it a type. So what is a type? So for example, if I was storing data about someone's age is a number. So we need to give the type needs to be a type of a number, right? And age is a whole number, so we can use an integer. Now an integer in Java is just simply int. So that is the type. Notice how it's gone yellow? So it's recognized that this is an integer called name, and now it needs to be a value. So let's change the name to age. And let's give it the value, let's do 25. So now we've said age equals 25. So now anytime we point to age in our code further down, it will be referencing 25. So like above, we can copy this print statement. So this piece of code here, by the way, literally just prints whatever you provide it. So if we take that, and instead of printing hello world, let's print age. Okay, so if we click run, notice here it's printed out 25, because every time you mention age, it refers to this variable here. It refers to 25. You cannot have a variable called the same thing. So if I do this, it's going to complain because age has already been defined. So here you'd have to call this age2, and that's how it would store 50 in age2, because otherwise, if they're both called the same thing, Java wouldn't know which one to print because there's two competitors. So the fact that this is orange is great because this is telling us that this is a primitive type. Now that might sound a bit scary, but a primitive type is just basically, there's 8 primitive types in Java, and they're just the absolute basic data types in Java. So just to give you an example of another one, you can do Boolean. Now Boolean is simply a true or false. So you can say, am I good at Java? And we can set this to true. Or we can set this to false, but let's not do that. But so a Boolean value is true or false. Okay, so if we print it out, am I good at Java? You'll see here, it prints out true, right? So Boolean is a true or false value. Int is an integer or a whole number. You even have double. So if you want to store decimals, so you can just call this decimal value. and we can give this a value of 4.5, for example, and this would work absolutely fine here. So if we print that out, you see that we've now pointed to decimal value, which has the value of 4.5. So if you try to make this a decimal, by the way, it won't like it, because an integer does not have decimals. So this is literally saying that you've provided a double. So we've provided a double, but we're expecting age to be an integer. So this is what an IDE does, by the way. It gives you really cool hints. It tells you what you've done wrong, gives you some good ways of fixing it, and it highlights errors before you even run your code, because this will actually stop you. So you'll see that when you, if you run the code, it actually won't compile, right? So let's get rid of that, and there we go. Now we're all sorted. So now we've printed. So what we've done here, by the way, is a method call. So we've called a print method, which is taking the value and then it's outputting it into the console, right? But we can do other stuff. So we've seen some primitive types. So let me show you some non-primitive types. You will identify primitive types, by the way, from the fact that these are all lowercase. So an example of probably the most popular one that you guys will be using, as well as we can write these in non-primitive types as well, is string. So what you see here is a string. So you see these double quotes. So this quote is the start of the string, and in here you can put any character you want and it will store it. So strings are great for storing kind of like words, for example. So let's create a variable. So remember, we start with the type. So the type is string, and let's call it name, and let's give this a name, Java role. Okay. So we've now assigned this a name. So now if we print name, it refers to a string. So this would now print the value of the string, which is Java bro. So same way here, we can store this in a variable called hello world, and that can equal this string over here. Paste that there. So now if we reference hello world and we run that, it will do exactly the same thing as it was doing before. Okay. If we didn't have this, you'll see that IntelliJ is complaining, right? By the way, this is called a comment. So if you add these two forward slashes on any line, you're basically telling the compiler to ignore this portion of code, right? So maybe you've written something that you're playing around with, but it doesn't work, but you want to leave it there. You don't want to just delete it. You can add these two slashes and it will just be ignored. But because this is ignored, IntelliJ is complaining that, what is hello world? You've just written hello world, but I don't know what it is. So we need to remove these to tell IntelliJ that this is a variable that we have stored, okay, to tell Java that this exists. So that is essentially kind of how types work, and this is a primitive type for age, okay? The non-primitive type for age is integer, okay? It's exactly the same thing, so we can call this age2, and we can also equal it to 25. You might be wondering, why would you want to use this if this already exists? Okay, you can do so many more things with non-primitive types. These are incredibly basic. So for example, with Java bro, name is of type string. So if I actually add a dot here, I can do any of this stuff with a string, okay? Because it's non-primitive, it has methods. These are called methods. So these are blocks of code that someone has written that when you call it by writing the name of the method, we're going to create our own, so don't worry, I'll go through it. It will perform whatever's in that block of code. So for example, if I select the 2 uppercase here, so what this will do, this will take name and this will perform this action to name. So as you can guess, it will print it in uppercase. And same for, so like we've got this integer here, right? So we can do, let's do new line. And by the way, a very nice shortcut to get that print line bit of code, it's just by simply writing s out. This literally, if you click enter now, you notice how it does system.out, and this is the benefits of using an IDE such as IntelliJ. So now if we do age2, which is of type integer, you see here it's telling you the type here as well as the name of the variable, and you can see that it's got a v to tell you it's a variable, and you've got an m here to tell you that these are all methods. So don't worry too much about these. So let's focus on the variable age2, which is referencing this one up here. Because it's a type integer and it's not primitive, we have access to loads of methods, okay? So we can actually convert this to a double. So we can actually convert this into this kind of type. So that's quite handy. You can convert it to a string. So if we did that, it's kind of unnecessary because we're just printing it out anyway, but what we could then do is do something like this. We could do string age2 as string, gotta uppercase that, and we can do age2. Notice how this won't work because age2 is an integer and we're trying to equal it to something that's of type string. So if you hover over this, this is actually saying that your required type is a string, but you've given it an integer. But now we know that there's that method, we can click the .toString. And now this will convert this into a format like this. But obviously you're not really going to notice anything because if you do system out age2 as string, notice here we're also printing out age2. It kind of looks the same, right? But just know that behind the scenes it's changed into a string, right? So methods. So you've already seen a method here, okay? So this is called the main method, right? It executes from this line all the way to line 21. And basically what we're doing is when Java's running, we are essentially calling this method. We're telling it to call the main method. So how do you call a method? Well, we've already called a method here, right? We've called the toString method, which is part of string. Okay, we've called the uppercase method, which is found in string. Sorry, the toString method is found in integer. Okay, but we can create our own. Sometimes you're going to repeat a lot of code. So, for example, see how we've got string name here. What if we had another name? So let's do string name 2 equals Amy. Let's do it like that, and maybe we've got another person called, let's do name 3, and let's make this equal to Luke, right? And we wanted to just print their name. So what we'd probably be doing, I tell you what, I'm going to delete this, I'm going to delete this, and I'm going to delete anything. So anything that's light grey, kind of like this, it means it's not used. And so, like, for example, the reason why name is there, if you double click it, it will show you where you've used it, whereas here we've not actually used it, so it doesn't show up anywhere, right? So let's actually delete these, and we'll delete the hello world up here just to make it nice and clear what we're doing. Okay, so if I wanted to print these names out, I would have to physically do this. I mean, of course this is going to do it to uppercase, right? And I'm going to have to pass in the one that we want to uppercase, so here and here. Okay, so if I now run this, see, it's printed out Java Bro, Amy and Luke. But I don't want to keep having to write system out print line every time I want to print a name and put it to uppercase. So we've got to create a block of code that does that for us. So to create a method, exactly like you can see here, because this is an example of a method, we've got to give it kind of an access modifier, but don't worry too much about that. We'll just stick with public, which means it's accessible anywhere. Static, again, don't worry too much about that. Void is your return type. Now, void just means it doesn't return anything, okay? And main is just the name of the method. And this here, this portion here is known as your arguments. And I'll explain exactly what that means in just a second. But first of all, let's create our own method. You can't create a method within a method. So we have to find where this method ends and create our own method here. So I'm going to move this down so you can kind of see this. And let's do public static void. And we now have to give a name. So we can't have a method called the same thing unless it's a bit different. And I'll explain that again. So let's say, what do we want this method to do? So we want it to print name to in uppercase. Okay. And here we can actually do our print. Okay. So in fact, let's just test this out first. And to test it out, let's just print. This is in the. Let's copy this name. Method like that. Okay. Now, if I run this, you'll notice that it didn't print that message. The reason why is because we haven't actually called this method. Notice how this is also grey, like greyed out, and if you hover over it, it said this method is never used. So remember, for a method to execute the code within these brackets, it needs to be called. This is an example of us calling a method. So if we get rid of this, or let's leave this for now. Actually no, let's get rid of this and let's call our method. So let's call print name in uppercase. See, IntelliJ's picked up that we have a method called print name in uppercase, as you can see by the M. Let's click enter here. Now you see that this has gone yellow because it's now been used. So now if I press run, boom, we are now executing this bit of code right here. Now what we want to do, what we were trying to solve, the problem we were trying to solve was we wanted to avoid writing system.outprint for each name, okay? We just want to print everyone's name in uppercase kind of seamlessly, right? So what we can actually do is pass the name to this method. Now I know that might sound confusing, but stick with me. And to do that, we need to provide a parameter. So notice how this indicates you're calling a method, right? So you have the name of the method plus the brackets. This indicates you're calling this. Notice how they match, okay? What we're going to do is we're going to add a parameter. Similar to like here, they've got some arguments here. We're going to add our own arguments or parameters. And what we have to do when you're taking in parameters into a method, you have to state what type the parameter will be. So for example here, we want to print a name, right? And a name is of type string. So we want to say this method takes in a name which is of type string. So this can be anything you want. This is just the same way as writing this. This is the name of the variable, okay? And let's just call it name so it's consistent, okay? Notice here that this is underlined in red. The reason why is now this does not match this, does it? Because this has now added a parameter called name. So we now have to provide a name here, and luckily we've got access to 3 names. So let's just start with the first one, name. Okay, what we've done is we've passed in JavaPro into this method. So now JavaPro will exist here. Okay, we've not used it, but it exists because print name in uppercase takes a string of name, and we've passed in this variable which contains this value. So now name is JavaPro. So what we can do now is we can just take in name like that. And if we now run this piece of code, there we go, it's print JavaPro. And that's because we've passed it in as a variable, as a parameter. So this variable is here, then it's here, and then it gets used here. So this is telling you what this method has access to. Okay, so this method has access to this name. And it doesn't stop there. You can take in more than one. So you can take in a string, another string called name2. You can take in another string called name3. Yeah, you could even take in a number. So we can take in an integer called age, or let's just call it number, just for simplicity's sake, right? And now as you can see, this is complaining because this does not match this, does it? This needs 3 names and a number, but we've only given it 1 name. So let's give it name2, let's give it name3. Okay, it also needs an integer. We haven't got an integer, so let's create one. So remember, we referenced the type first, which is, can't seem to spell, int, and we'll just call it let's just call it integer, and we'll give this the value of 5. Yeah, and now we can pass that in here like that. Okay, so now we've given it the name, we've given it name2, we've given it name3, and we've given it an integer which will get mapped to this number variable over here. Now we can do system out print name2. Now we can do system out print name3, and now we can do system out print the number that we passed in. Okay, so these are now able to be used here, and if we rerun the application, look at that, we've got JavaBro, Amy, Luke, 5. And the benefit of this is sometimes you don't want to clutter your main method here, right? You want this to be as clean as possible. So sometimes it makes sense to create blocks, methods which execute a block of code, because otherwise this would be in here, right? And the beauty of this is now you've got a blueprint to continue using this method. So for example, you don't have to use variables, by the way. So we've created a variable called name and a variable called Amy, but here we can directly write a string. So we can do this again, and we can write Jeff, comma, we can write another name, and notice here it tells you which one you're referencing. So this is why IntelliJ is brilliant. So we can do Bob, we can do Lacey, we can do Anne. Oh wait, no, this is a number. See, this says number, so this was not a string, so we don't need double quotes. So a string starts with these double quotes. Okay, and let's give it a number 100. Okay, and this will work. So notice I didn't have to keep rewriting these lines of code. It's a method, so every time I call the method, it will do these lines of code with these variables. So now that's great, right? We've been able to create a method, a void method, so this doesn't actually return anything, it just does something and then it exits. Okay, but now what if we want a method that returns something? So how about this? Let's create another method here called, and we'll just follow the same pattern for now, and we'll call this add to numbers, like this. Oh god, let's just call it add two nums. Okay, and let's say this takes in two numbers because we want to add them together, right? So this takes in an integer, and we'll call this num1, and we'll create another integer called num2, and remember we need to add the curly brackets so it knows that these are the lines it needs to code every time this is called. Okay, we need to call this method here, but let's make this method do something. So let's make it print number1 plus number 2. So we're doing an addition here, which should add number 1 and number 2 together. We can also do this in a variable. So let's create a variable called int result, and let's say that this equals the number 1 plus number 2. So we're actually saying that result is this value. So if you add these two numbers together, that's when you get result. So then we can directly print out the result. Okay, we can just do this in here, but this is just another way of showing you. So now let's just delete this for now, and let's do add two numbers, and let's give it two numbers. So let's give it 10, and we've also got an integer there. Let's just do 10 plus 5, okay, because integer references 5. So if I run this code now, see, we got 15. Perfect. So that's all working great, right? But what if we, instead of doing a void, let's actually return the result back, and then we can do whatever we want with it after, right? Sometimes we might not want to print it, we might want to do other stuff with it. So let's give the user of this code the flexibility. So instead of doing nothing, so void literally means nothing, right? Let's return an integer. Okay, so what we're saying is add two numbers will return a number back. So rather than printing that number, let's return the number. So the number we want to return is result, because result is the value of the two numbers added, right? And if you actually hover over this, it's actually telling you that there's a better way of doing this, because we're creating a variable and storing number 1 plus number 2, and then we're just simply returning the result which we've stored. But what this is saying is if we click inline variable, we might as well just directly return numbers 1 and 2 added together. We don't need to create a variable and store it and then return it, because we're not doing anything with that variable apart from returning it back to the user anyway. So we don't need to even create it, because there's no point using a storage box up if you're not going to use it, right? So now we've returned it back to the user. So if we click run now, notice how it's done nothing. See, we can't see the number 15 anymore. The reason why is we haven't stored this, so now it's worth storing the result. So now we can do int result equals. So we're saying the whatever this method does, store it in result. And the reason why it's an int is because you're returning an int. If this was a double, for example, like that, this would complain because you're returning a double, but we're storing it in an int. So these have to match, of course. So this, let's change this back to an integer. So now we've got the result, and now we can print it out. So now we can do print result. And if we click run, result will hold the value of this, which is why we get 15 back. Okay, and this is great. And what IntelliJ actually lets you do is you can actually hover over this, and it will actually kind of show you kind of a little simple version of your method. So for example, if like we had the two uppercase, if we did the uppercase over here, so let's see if it let us do it here. Yep. So if we did two uppercase here, you can actually hover over this, and you've got kind of like this nice little text, and it tells you there, look, it says converts all the characters in the string to uppercase. So this is great of knowing what method does what, and if there's any documentation available, right? So that's great. We've actually created a couple of methods now, right? The next thing I want to show you guys is conditional statements. Now, conditional statements are great, okay? So it's kind of the basics, the building blocks of building like logic, right? Because everything in programming is logic based. So what conditional statements are is, if something is this, then do this, otherwise do this. So the simplest way of writing it would be writing literally writing the words if, okay? And then you have to give it brackets. Now inside the brackets you have to give it a condition, okay? So for example, if you could, we've got an integer here that's equal to 5, so we can do if integer equals 5, and now this is how you equal something in Java, okay? Then say you printed you have the number 5, okay? And then else you can do system out, you do not have the number 5, okay? And this is highlighting this because this is always true, because we've hard coded integer to 5, okay? So if we run this piece of code here, okay, notice how it prints you have the number 5, but it doesn't print this. The reason why is because this is true. If this is true, it will print this out. If this is false, it will print this, okay? So now what we can do is we can do integer equals 10. Notice how we didn't have to write int again, because we've already created integer, right? All we're doing is changing the value. So at this point of the code, integer will now be 10. It will no longer be 5. So let's copy this if statement like that. And now if we rerun it, in fact, let's actually say you do not have a number 5. Instead, you have the value and then plus integer. So this will tell us what value we have, okay? So if we run this code now, and I'm going to use this top one, see? So the first time it prints, I tell you what, let's make this even clearer. So let's print here, we have changed integer to 10. So if I now run this, at this point integer has now been changed to 10, and now you can see that it goes into the else statement, okay? So we can do, let's create another one, let's call it this, let's create one here and call this int another int, and let's call this 10, okay? So we can say if integer is equal to 5, but here what we can do is do else if. This is another if statement inside an if statement. So if this is not true, it will check this one, and if that's not true, it will go to else. So we can now do if another int equals 10, let's make it 15 actually, just so it's completely different. So if another int is 10, execute this line of code, you have the number 15, like that. So if we run this code, there you go, you have the number 15. So if, then you got else if and else. You don't have to use all of these together. You can literally just use if. You can only use else and else if it's followed by an if. So this is absolutely valid. Sometimes you'll only need an if. You know, sometimes you only want to do certain things if something is true, and then carry on, right? So that's a very basic if statement for you guys there. You can even do stuff with strings. You can do stuff with Boolean values. So if you remember, Boolean is true or false. So you can create a am I cool false, because I don't think I'm very cool. And you can directly put am I cool, because this is already true or false. You don't need to write equals true, because it's already true or false, right? And you can do you are cool. Now to invert this, if you add an exclamation mark, this now says if this is not true, do this. So if I run this, oh wait, you are not cool. Let's play that again. Now this executes because this is false, but we're expecting false because we've inverted it, right? So if I get rid of that, you'll see that it won't work. See, we didn't get it because, well, we've marked this as false. So this goes to this line. Is this true? No, it's not. So ignore this, go to the next line of code. Okay, so that's very, very simple if statements for you guys. The next thing I want to teach you is looping. So let's actually clean this up a bit and let's delete stuff we are not using. Okay, let's actually get rid of this as well. So what if you wanted to do something a set number of times? So let's print I like pizza, because who doesn't like pizza, right? So if we press play, it just prints out the statement, right? Now I want to really express how much I like pizza. So let's let's just say we want to print this a lot of times. Okay, there we go. So now if we click play, it's printed out a few times, but I don't want to have to keep writing this, because what if I wanted to print this 1,000 times? I'm not going to be sitting here all day and pasting this line, right? So that's why we use something called a for loop. Now a for loop is written like this. So you write the word for, and inside this bracket you have to create an integer variable. So you guys should be able to do that now. So we create an int. Usually this is called I, and then we make this equal to 0. But for simplicity, let's call this count so it makes sense. So this is a counter. We've created a variable called count that will store an integer, and we're going to start it out at 0, which is why we're equaling to 0. So we're going to close this by adding a semicolon. That's how you close a Java statement, by the way, if I've not mentioned it already. Every line needs to end with a semicolon. If you don't have a semicolon, IntelliJ will complain, right? And it says it expects this. So make sure you add your semicolons at the end. The next step here is we have to give a condition. So what we're trying to say is we want to print I like pizza 1,000 times, or let's just do 5 times, okay, just for simplicity. So what we're going to write is count is less than 6, okay, and then we're going to end that in a semicolon just like that. And then what we're going to write is count plus plus. Now this might seem really confusing. Oh yeah, don't forget we have to add the curly braces at the end as well. This might look a bit confusing, but I'll explain to you exactly what this means. So we've created a variable called count and it equals 0. What we're saying here is if count is less than 6, execute whatever's in these brackets in between here, and then once you've done all the code in here, count plus plus will add 1 to count. So now count is 1. So is 1 less than 6? Yes, then execute this code here, add 1. So now count is 2, okay? And now 2, and so on and so on. Eventually we'll get to 6, right? Where count is now 6 because we've added it quite a few times. Is 6 less than 6? No, it's not. And that's when it exits and carries out the rest of the application. So let's delete these and let's copy this in here. And let's get rid of this, okay? And if we run this now, see that? It's still printed out 6 times because each time it's adding 1 and it's going to print it. So now I can set this to 1,000. This will be interesting, but let's click run. And would you look at that? I like pizza. Do you know what? That's not good enough. I think love is a better word. And let's do it 100 times. We don't need to do 1,000. You guys have seen that in action. And there you go. It's printed I love pizza 100 times. Okay. And this is a great way of saving, writing the same thing over and over again. Now this is only applicable if what you're writing is the same exact thing every now and then. The other thing is you've always got access to count. So if you want to know count, you can do system out, and then we can do value of count is and then plus count. So if we press play now, so you can see exactly what I was saying at the start. Count starts off as 0, and each time it adds 1 at the end. So after it's printed this out, it will add 1 to count. So now count is 1, now count is 2, and all the way down to 99, because 99 is the last number that is less than 100. When it gets to 100, it will stop. If you want it to print 100, if you do an equal, so this is going to say if count is less than or equal to 100, then it will print. So if we click run, and you can see it's included 100, right? So that is a very basic for loop, okay? The next thing we're going to show is Java is something which is called an object-oriented language. So sometimes it makes sense to separate your code into separate files, right? So let's delete this for loop for now, and let's create a new file. So if we right click on this source folder, this is the home of your Java code. So let's right click source, click new, and let's click Java class. So Java class is just a file containing Java code, okay? So let's click that, and we want to make sure it's selected to class, and let's call this, let's do a dog, okay? A dog class. Now what we do is we write any code that's related to a dog in here, but what we can also do is we can create our own dog, and I'll explain exactly what I mean by that. But for starters, let's just create a method, okay? And let's make this method void. So let's follow the same thing that we were doing before, but we don't need static. Now the reason we don't need static is the main method is always static. So you will see static on some methods, you won't see static on others. But look, if I don't make this static, it means you need to create an object of a dog to use it. However, if I make it static, it doesn't need an object, and I'll show you exactly what that means. So let's call this bark, okay? So this is how we create a method. Remember, we have to include the brackets, and we don't need any parameters, we don't need to take in anything, but we can just system out woof, okay? Now to use this in our main, so this is a completely different file, we simply just write dog, and look, there you go, it's picked it up that we've created it. So we've now actually created our own type, by the way. So we can do dog dot bark. So this is the method that we created, right, in dog. See, and now it's gone yellow to say it's been used, and it even says 1 usage. If you click it, it shows where it's used. So if we run this now, it will run our method, and there you go, it's printed out woof. So let's create a non-static method, and you'll see what I mean. So let's just take away static. And it's told us there's a problem. So notice here that this says non-static method cannot be referenced from a static context. What it's saying is we need to actually create a dog. So think of this class dog as a blueprint, okay? So a blueprint, you know how you can use a blueprint and make several things using that blueprint, right? So that is a way of kind of creating objects. So objects are things that we can interact with. And an object has properties and it has methods. So what I mean by properties is, what properties would you say a dog has? So let's start with a name, okay? And a name is a word, so we can store that in a string. So let's do name. Now here, there we go. Notice here we're not equaling it to anything. The reason why is this is a blueprint. This isn't the final thing, right? So we don't need to give it a value, because when we create an object or create our own dog, we can give it a name then, right? So let's say it has a name. The other thing it has is a age, right? And let's use the non-primitive integer for this. And let's give the dog an age. Maybe we'll give it a breed property. And yeah, that will do for now, okay? So these are just 3 properties. So now what we can do in our main class is we can create an object from this class. So this is the blueprint for a dog. Now let's actually create a dog. So what you do to do that is you put the type, which is dog, and then you give this just the same way you were creating a variable. So let's call this my first dog. Okay, this is the name of the variable, because what we're doing is an object is basically a variable, okay? Equals, so this is exactly the same. But to create an object, we do a keyword called new. And then we have to reference the class. So the class is dog. So my first dog is a new version of this class, right? So at the moment, this is completely empty, right? because if you do dog dot, you can access, oh sorry, it's my first dog, isn't it? So if we now call my first dog, and if you do dot, notice how we can access those properties that we added. But if we did name like that, you'll notice here you can't exactly use it because we haven't actually assigned it. So what we need to do is my first dog dot name equals, and let's call it Doug for dog. Okay, and now if we do system out and we do my first dog dot name like that, and if we run it, notice how it prints Doug because our dog has been given a name. So that's just one version of a dog. Underneath this we can do dog my second dog like this, and that also equals new dog. So we've used this blueprint twice to create completely two separate objects, right? And these are completely separate from each other. So my second dog dot name is, let's give it a name of, I don't know, Angelo. It's an interesting name for a dog, isn't it? But Angelo, and again we can do the same exact thing. My second dog dot name, and these are completely separate dogs. See, we've got Angelo and Doug, and the same way we can do my first dog dot age and give it an age like that, and same like this here, equals to. And in fact, if you just get rid of dot name here, and if we just run this, look what happens. Notice how it prints kind of like this weird looking thing. This is actually kind of like the hash, or this is the actual object. Notice how they have different, think of it as an ID in a way. You can see that they're completely different objects because they have a different ID, right? But what we can do now is we can actually call the bark method. See, now we have access to bark, right? And the reason why that's erroring is because bark itself does a system print. It doesn't return anything. So instead of doing this, let's do my first dog and tell it to bark. And then we can do my second dog dot bark like that, right? And if we run this code, there's my first dog barking and that's my second dog. To make it more interesting, let's take a parameter and call this, we'll make it a string, and we'll do, and it takes in a bark, and instead of printing out woof, we'll print in the bark. So let's say, oh, I tell you what, let's actually do it as a property. So let's add a bark type property. Okay, so what we'll do now is get rid of this, and it will print out bark type. Okay, so this is the blueprint using its own property in its own method. Okay, and I'll show you how that makes sense, because now we can say my first dog dot bark type equals, let's say, rough. Yeah, and let's say my second dog barks a bit differently and goes woof woof like that. And if we click run now, see, notice how the first dog does this and the second dog does this. So this is a very simple version of object-oriented programming, where we are creating an object from a class. Okay, and a class contains all the relevant properties and all the relevant methods for dog. So it doesn't make sense for me to create a method that does drive, drive, because dogs don't drive. So this would be a bad example of programming, right? You just rather do things that dogs do, like sleep, and then we can print out z z z z z like that. So now if we make our dog sleep and click run, there you go, dog 1 is now sleeping, right? So this is how we create an object, and we can set properties against this object to build up our object. And this is also an example of calling methods on that object, and the difference between static and non-static methods. Static means it doesn't need an object to be created. A non-static method needs an object of that class to be created. So if we did add if we made this static like that, you'll see that this is now complaining because it doesn't need to be called on an object. It can just be called directly from dog.sleep. So if we run that, it still works, okay? So that's very basic kind of Java for you to just get your teeth sunk into. So give it a go, just have a go making your own kind of like object and making your own class. You know, you can go crazy, create one like a car, you can create one that's a cat, you know. Have fun with it and just keep practicing. Practice creating variables. So this is a variable called dog, but technically it's an object called dog because it's got this keyword here. But these are all properties of the class. But remember, a variable is just a type, name, and value. Okay, technically this should be type. So the type can be anything, so like a string for a word. Name makes sense because a name is a word, so it can be a string. And then give it a name. Just like that. And remember to add your semicolon. So I hope you guys enjoyed the video and I hope you guys learned some basic Java programming from it. Remember, practice makes perfect, so I highly recommend you go away and practice the concepts that you've learned today. If you enjoyed this video, please do leave us a like and subscribe to our channel, and we look forward to making some more Java content for you guys. Thanks guys, have a good day.